Okay, we're trying some more discriminant problems. So these questions are going to ask me to find the value of p, or values of p, such that the roots are equal. So if the roots are equal, then we know that the discriminant is equal to 0. So let's try this one. X squared plus 2p plus 1 is equal to 2 bracket p minus 1x. So let's first of all make the thing equal to 0. So x squared minus 2 bracket p minus 1x plus 2p plus 1 is equal to 0. So I've just moved this over and changed its sign. So a is equal to 1. B is the coefficient in front of x, so that's minus 2 bracket p minus 1. And c is everything else, so that's 2p plus 1. Okay, so we know that the discriminant is equal to 0. So b squared, that's going to be minus 2 bracket p minus 1 all squared minus 4 times a, which is 1, times c, which is 2p plus 1, is equal to 0. So we're going to square both elements here, so minus 2 all squared is 4, so that's 4 bracket p minus 1 all squared minus 4 bracket 2p plus 1, close the bracket, is equal to 0. Okay, so let's take our time with that. That's going to be 4 bracket p squared minus 2p plus 1. So that's the result of squaring p minus 1, but it's 4 times that. Minus 8p minus 4 is equal to 0. I'm going to take this down a wee bit. That will be 4p squared minus 8p plus 4 minus 8p minus 4 is equal to 0. That's 4p squared minus 16p plus 4 minus 4 will cancel out, is equal to 0. Take a common factor, which is 4p, bracket p minus 4 is equal to 0. So now I've got 4p equals 0, or p minus 4 is equal to 0. So that's p equals 0, or p is equal to 4. Okay, so next question. For what value of k does each equation have real roots? So the condition for real roots is that the discriminant is greater than or equal to 0. Okay, so the first one, we've got x squared minus 4x plus k is equal to 0. So a is equal to 1, b is equal to minus 4, and c is equal to k. Okay, so for what value of k does each equation have real roots? Real roots occurs when the discriminant is greater than or equal to 0. Okay, so minus 4 all squared minus 4 times 1 times k. So that will be 16 minus 4k is greater than or equal to 0. So minus 4k is greater than or equal to minus 16. Remember, for solving linear inequalities, that you solve them like linear equations, except if you need to divide through by a negative number, you must flip the inequality round. So you do so at the point of division by the negative number. So we're about to divide through by negative 4. As we do so, flip the inequality round. And then minus 16 divided by minus 4. Well, the two negatives cancel out, and 16 divided by 4 is 4k is less than or equal to 4. Okay, next one. 2x squared plus 20x plus k is equal to 0. And again, it's to find k when each equation has got real roots. So real roots occurs when the discriminant is greater than or equal to 0. So a is equal to 2, b is equal to 20, c is equal to k. So that's going to be 20 squared minus 4 times 2 times k is greater than or equal to 0. That'll be 400 minus 8k is greater than or equal to 0. Minus 8k is greater than or equal to minus 400. I'm about to divide through by a negative number, so flip that inequality around to less than or equal to minus 400 divided by minus 8. And the two negatives cancel out. 400 over 8 is 50k is less than or equal to 50. Okay, next one, same again. Find the value of k for which the equation has got real roots. So the discriminant being greater than or equal to 0. This time we've got kx squared plus, in a bracket, 2k minus 3 lots of x plus k is equal to 0. So a is equal to k, b is 2k minus 3, and c is equal to k. Okay, so 2k minus 3 all squared minus 4 times k times k is going to be greater than or equal to 0. So that's going to be 4k squared minus 12k plus 9 minus 4k squared, since 4 times k is 4k squared, is greater than or equal to 0. 4k squared minus 4k squared, they cancel out, so I've got minus 12k plus 9 is greater than or equal to 0. Minus 12k is greater than or equal to minus 9. I'm about to divide through by a negative number, flip the inequality around. Minus 9 over minus 12. Two negatives cancel out, 9 over 12 comes down to 3/4. K is less than or equal to 3 over 4. Okay, next one. Find the value of k again for which the equation has got real roots. So again, condition for real roots is the discriminant greater than or equal to 0. So we've got x bracket x minus 4 plus 2 is equal to k bracket 2x minus 3k, so it's just going to be a bit awkward now. Okay, so let's first of all bring that across. So that'll be x squared minus 4x plus 2 minus k bracket 2x minus 3k is equal to 0. So it's x squared minus 4x plus 2 minus 2kx plus 3k squared is equal to 0. Okay, so let's put this in some ordered fashion. X squared minus 4x minus 2kx plus 2 plus 3k squared is equal to 0. Now we've got a slight issue here, which is that we've got multiple x terms. So identifying b could be tricky, but it's actually quite easy if we just think about it clearly. Take out a common factor of x, and then whatever's inside the bracket will be b. So that would be minus 4 from here and minus 2k from here, plus 2 plus 3k squared is equal to 0. So now we've got a equals 1, b is the coefficient of x, that's what's inside the brackets, that's minus 4 minus 2k, and c is everything else that's not in front of x squared or x, so that is 2 plus 3k squared. Okay, so minus 4 minus 2k all squared minus 4 times 1 times 2 plus 3k squared is greater than or equal to 0. So that's going to be 16 plus 8k again plus 4k squared minus 4 bracket 2 plus 3k squared is greater than or equal to 0. So 16 plus 16k plus 4k squared minus 8 minus 12k squared is greater than or equal to 0. Okay, so 4k squared minus 12k squared is minus 8k squared plus 16k plus 8 is greater than or equal to 0. Okay, we can see quite clearly now that we've got a quadratic inequality. Therefore, to solve it, we'll need to sketch a curve. Well, the first thing to note is that it's a negative k squared in this case as opposed to a negative x squared, but that means it is absolutely concave up. Let's now find the roots by making the thing equal to 0. As soon as it's equal to 0, I can change all signs to make it easier for me to factorise. Then take out a highest common factor of 8, bracket k squared minus 2k minus 1 is equal to 0. I can then divide both sides by 8, which will give me k squared minus 2k minus 1 is equal to 0. Two numbers that multiply give minus 1 and add together to give minus 2. Okay, so that's looking tricky to factorise. So an alternative could be to use the quadratic formula. So quite a tricky question. A is equal to 1, B is minus 2 and C is minus 1. So if B is minus 2 minus B would be 2 plus or minus the square root of minus 2 all squared minus 4 times 1 times minus 1 all over double A. That's double 1, that's 2. Minus 2 all squared is 4. Minus 4 times 1 times minus 1 would be plus 4 all over double A. That's 2. Four plus 4 is 8, so inside the root is that. And then that would be 1 plus or minus root 8 over 2. So that's 1 plus or minus 2 root 2 over 2. X equals 1 plus or minus root 2. So my two roots then are 1 minus root 2 and 1 plus root 2. So remember that this was a quadratic inequality and it was concave up and we were looking for where the thing was greater than or equal to 0. So 1 plus root 2 and 1 minus root 2, it was concave up, and that would then be in between 1 minus root 2 and 1 plus root 2.